Okay, in this video we're going to have a look at another region of space, but we're going to do an accurate diagram this time, and we are going to make things a little bit more difficult because the region that is going to be concerned with needs us to plot a boundary 2x plus 3y less than or equal to 6. In other words, shade all the points which obey that set of conditions. And that is going to be slightly different and slightly more difficult to what we've done in the past. The first two boundaries, x equals minus 2, we'll need to plot. Well, that's straightforward. Y equals minus 3, that's also straightforward. So they're going to be similar to previous questions we've done on previous videos. But the third one needs us to plot 2x plus 3y is equal to 6. Now that is not in the form of what we'd normally expect a straight line name or straight line equation to look like. Normally you have y equals so many x's plus a number on the end. So one way that you can deal with this more awkward form of a straight line, because that is the name or the equation of a straight line, it just doesn't look like it is at the moment if you're used to seeing it in the form y equals. What you can do is use some algebra manipulation to get y on its own. What we do is we make use of something called the change of subject of the formula, which you may be able to access on another video in our algebra section of videos. So I'm going to make y the subject of this formula. So how am I going to do that? Well, if I just take that equation there, if I leave the 3y exactly where it is, I'm going to take the 2x to the other side, and it will become a minus 2x from our basic manipulation of algebra rules. That 6 started on the right, I'm going to keep it on the right. Now it's a plus 6, there's a plus sign in front of it even though you can't see that plus. If you leave it there, it stays as a plus 6. So what you can see is that 3y is equal to minus 2x plus 6 actually is the same as what we started with. They are the same thing, just manipulated. However, it's still not of the form y equals so many x's and a number, which is how I normally see straight line graph equations. So what I'm going to do is share that by 3. So I share that by 3, I get a single y. That is exactly what I want. Now remember, if I'm going to share this by 3, I've got to share the other side by 3. Now there are two ways of doing this. When you're doing a share by 3 for that, you can either, don't copy this down if you're copying notes, you can either put a bracket around the whole lot and say share by 3. That's okay, nothing wrong with doing that, that is perfectly fine. Or, alternatively, you can share them individually by 3, one at a time. So, share that by 3, share that by 3, share that by 3, and that is still okay if you do that. So, you either write it as minus 2x plus 6 and share the whole thing by 3, or alternatively, you're able to share things one at a time by 3. Both are acceptable forms of the y equal equation. Now if we want to get it in the form y equals so many x plus a number, then this is the format that we will use. So you get y equals minus 2/3 x plus, and then 6 shared by 3 is actually a whole number 2. So I'm going to write that down, and as you can see, here now is the equation of a straight line in the form that we're used to dealing with. And that's the form that has been given to you in the past in previous questions. Okay, we've got an awkward gradient value of minus 2/3. But if we choose our points in a table of values we're going to do in a minute carefully, it will not be a problem. Okay, so, table of values for this then. Now it's in the right format, y equals so many x's plus a number. So table of values, x and y, like so. 3 points I'm going to pick. I'm going to pick x equals 0, because x equals 0 is really easy to work out, because y will be minus 2/3 times nothing. Well, that's just nothing. Plus 2, you get 2. So by picking x equals 0, that's really simple. Next, what I'm going to do is pick the value x equals 3. Why 3 and not 1? Well, if you think about it, what I've got to do is minus 2/3 times 3. Well, if I just do that underneath, minus 2/3 times 3. And that really is 3/1. As a fraction, 3 can be written as 3/1. Because I picked 3, those two 3's from your rules of fraction cancelling can cancel each other out. And so what you end up with is just simply minus 2 over 1, which is minus 2. So minus 2/3 multiplied by 3, the 3's cancel, leaving just minus 2. Plus 2, well, that's nothing. Okay, so if you're not happy with that calculation, let me do it again for you very quickly. Some of you might be a bit confused by that. So it's minus 2/3. I'm saying times it by 3. So I'm timing it by 3, which is 3 over 1. The 3's will cancel. It's the same as minus 2 over 1 minus 2. Plus 2, you get 0. Okay, in the same sort of way, because I know how this cancelling effect works, I'm going to pick 6. 6 is another number that if I put it there instead of the 3, it's going to cancel. So, if I do another calculation now, just to show you how easy this is, minus 2/3 times x. Minus 2/3 times by 6. 6 over 1 is the same as 6. We can cancel. 3 into 3, 1. 3 into 6 twice. That's how we deal with cancelling of multiplication of fractions. So we end up with minus 2 times 2, that's negative 4. Over 1 times 1, which is 1. So negative 4 over 1 is negative 4. Negative 4 is what that works out to be, plus 2. Well, negative 4 plus 2 is minus 2. So there you go. I've got 3 values which I can now plot on a graph. Okay, so the reason why I chose 0, 3 and 6 is because I knew 0, 3 and 6 would be easy to deal with that 3 on the bottom line, because we get this cancelling. If you don't like that and you can't see or you're not confident with the cancelling, then perhaps you want to take a look at one of the fraction cancelling videos on this website. Or alternatively, just use 0, 1, 2. And you'd have to be able to work out minus 2/3 times 1 and then plus 2. And you'll get a fraction answer coming out. But if you're happy with that, then you can do that. Okay, so I'm going to scrap that. I'm now going to plot this accurately on a scale picture. So, y-axis, x-axis. I'm going to say x is 1, x is 2. To plot this one here, I'd need to use 6 and minus 2. So 6 across and minus 2 down. Well, okay, I could draw this across the 6. If you don't have enough space, then just do the first 2 points. It just depends upon how much space you're going to take up. So I will do 3, 4, 5 and 6 on the x-axis. And the y numbers, I'll go 1, 2, up to 3, and I'll also go down minus 1, minus 2, minus 3. Okay, let's see if that's enough to plot. Well, the very first one is x equals minus 2, so I need to go down minus 1, minus 2 to plot that. X equals minus 2 is a vertical line dotted. So, dotted. And I need to show x values bigger than minus 2, so to the right, like so. Label it, x equals minus 2. There's the first boundary line in dots. Second, y greater than minus 3, so y must be equal to minus 3. So you go to minus 3 on the y-axis, which is there. No equal sign, so another dotted line, and this is going to go horizontally. That's y equals minus 3. Bigger than means above the line, like so. I'll put 4 arrows on that. So to the right of that and above that. Now the last one I need to plot from the table of values. So 0, 2. 0, 2 means on the y-axis there. 3, 0, 3 across and 0 up is there. Now in fact that's all I really need to join up with a ruler to get the boundary line. But let's just check that the third point is actually on this line. 6 minus 2, 6 across and 2 down is there. It's just gone into that little arrow, so perhaps if I rub that arrow out so I can see the plot. 6 across, 2 down is about there, like so. And it's equals. So what I need to do is draw a solid line passing through those points. So solid line with a ruler, obviously, passing through those points. And I'll label it with the original equation that they gave us. 2x plus 3y is equal to 6 is the actual boundary for that line. Now, to decide whether it's above or below, what you need to do is imagine that you've rearranged it like you can see here, so you get y on its own. So the y on its own stays on the left, and the symbol would be y on the left, and it's followed by a less than or equal to. So if I'd left the inequality in here, it would be a less than or equal to. Now, I'm not putting it at that stage there, I'm using equals to get the table, but if I had left the inequality, it'd be less than. So that means it must go below, because of the less than symbol there. So below, 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 below arrows, like so. So what I've got is to the right of the dotted vertical, above that and below the diagonal there. So the region of space, I'll do a different shading this time. I'll do this sort of curly effect shading, this shading like so. This is the region that I need to be showing to the examiner, and it's the triangle at the centre of those three boundary lines. So there you go. There is one way of dealing with a boundary line that's written in an awkward form, like 2x plus 3y, well, equals 6 is the boundary itself. What you need to do, remind you, is rearrange the equation to get from change of subject, y equals so many x and a number, and then you can use a table of values. Okay, in the next video, what I'll do is I'll show you an alternative way of doing the same question using a technique where we find intercept values on the axes to plot these awkward boundaries which are written like that. But that's for the next video.